We're going to look at the sign of trig functions in each, whether they're positive or negative, in each of the quadrants. And we're also going to look at what's called a reference angle. Okay, so if we have some angle theta, there's mirror images in each of those quadrants where we have identical triangles. They're just reflected up or back or down. Okay, so if we have some point x, y, the y value is related to the sine because sine of theta is equal to y over r. Now r, that's always positive. Okay, so that's always positive no matter what. So that doesn't affect whether sine is positive or negative. What affects whether sine is positive or negative is the y value. Okay, and so we're looking at which quadrants y is positive, and so that happens in quadrants 1 and quadrants 2. And its reciprocal cosecant would also be positive in quadrants 1 and 2. Now let's look at that x value. X is related to cosine. So cosine is defined as x over r, like we said earlier. R is positive. So we're just thinking about when is my x value positive, and that happens in quadrant 1, and then also in quadrant 4, because we'd go positive x and then down for y, so it'd be negative y, right? So we would have a positive cosine value in quadrants 1 and 4. And its reciprocal or secant is also positive there. Now let's think about tangent. So tangent is defined as y over x. Okay, so y, that's how far up we get from the origin to our point. So you can think of that like the change in y, the rise. X is how far over, that would be the run. So tangent is the slope of that radius. Okay, and the slope of the radius is positive. The slope of that radius is positive in quadrant 1 and in quadrant 3. So tangent is positive in quadrant 1 and 3. And that makes sense because in quadrant 3, we go back and down for x values, and so we would have tangent of our angle would be negative y, negative x, which ends up being positive. And then its reciprocal would be positive as well, that cotangent. Okay, and so we see that all our trig functions are positive in quadrant 1. Sine is positive in quadrants 1 and quadrant 2. Cosine is positive in quadrants, well, all of them are positive in quadrant 1, and then also in quadrant 4. And then tangent is positive, all of them in quadrant 1, and then also in quadrant 3. And there's a little mnemonic that some students find helpful. Only the sine is positive, and then people think of that as students. Tangent, so people can think of that as all students take, and then cosine, calculus, if that helps, if you like mnemonics. So all in quadrant 1, just sine and its reciprocal too in quadrant 2, tangent in quadrant 3, and cosine in quadrant 4. Okay, the reason that we look at that is because it can really help us to simplify our work a little bit to understand what quadrant we're in. Okay, so if the hint that I'm given for this angle is that the sine value is negative. So sine is negative, that's the y value, so that would be in quadrant 3 or quadrant 4. Okay, and then we also have that cosine is also negative. That happens when our x values are negative, which happens back in quadrants 2 and quadrants 3. So for those to both happen at the same time, we know that we're in quadrant 3. Okay, let's look at another one. So here we know what the tangent value is. Tangent is negative 4/5, and we also know that cosine is positive. Okay, tangent is negative. That's where the slope of the radius is negative. So that would be in either quadrant 2 or quadrant 4. Okay, cosine is positive. That's where my x values are positive. So that's either quadrant 1 or quadrant 4. All right, so both of those happen in quadrant 4. All right, now let's use the fact that tangent is given, and we know that tangent is defined as y over x. In quadrant 4, our x value is positive, so the y is the negative. That's what's creating the negative fraction there. Okay, so we have negative 4 over positive 5. Now we need to know what our radius is. If you're visual, you can look at that as, let's see, y is negative 4, x is 5. There's a little right triangle in there. We don't know the radius. The y or the x value is 5. The y value is negative 4. So that's just Pythagorean theorem. We also have a formula for that. So we have the square root of x, quantity squared, so negative 4 squared, and y squared. So r is the square root of 16 plus 25, which is the square root of 41. Now we have r, x, and y, and so we are supposed to find the sine. Okay, we'll use the definition of sine. Sine is y over r, and that is, let's see, y was negative 4, r is square root of 41. Rationalize the denominator. So our final answer here is negative 4 times the square root of 41 all over 41. And the next thing we're going to look at is something called a reference angle. There's different ways to denote it. Sometimes it has a bar over the top of the angle. Sometimes it has a little parentheses. Both of those mean the same thing. They're the reference angle. And it's the acute angle, just the shortest, smallest angle between our terminal side and the x-axis. Okay, so we would have, in quadrant 1, it's the same thing as the angle. In quadrant 2, it would be just how to get from that terminal side down to the negative x-axis. In quadrant 3, from the terminal side to the x-axis, and in quadrant 4, those all are the reference angle. Okay, so let's first of all just practice, and then we'll use reference angles and the sign, whether our trig functions are positive or negative, to help us evaluate trig functions. Okay, 107, that is in quadrant 2, and so the reference angle is the shortest distance from our terminal side to the x-axis. We're at 180 would be getting us all the way to the x-axis. So it's just the difference between 180 and our angle. Okay, so that reference angle there is 73 degrees. All right, we can do this even when we have quite a large angle. So 1,380, well, that's definitely more than 360. Let's just see how many full rotations there are. If we divide by 360, that'll tell us how many full rotations. What is that, about 3.83? All right, so that is 3 full rotations, and then some more, some about 0.83 of a full rotation. So let's just simplify this first before we try and figure out our reference angle. So a coterminal, let's find the coterminal angle. So we're going to subtract 3 full rotations. A rotation is 360 degrees. And we get 300 degrees. Okay, so the coterminal angle is 300 degrees. That's coterminal with what we started with. And now our job is to find the terminal or the reference angle, and that is the angle between our terminal side and our x-axis. Okay, so this angle right in here, that is the reference angle. Okay, so next step is find the reference angle. Now we haven't quite gotten to 360, So we're going to subtract how far we have gone, which is our 300 degrees. Okay, so the reference angle is 60 degrees. So if we've memorized the terminal points in quadrant 1, if we know what those terminal points are for 60, then that we could figure out all of our trig functions. We would just know the y is negative in quadrant 4. Okay, let's try a next one. We have 19 pi over 6. That is more than a full rotation. A full rotation is 2 pi, and in terms of 6, that would be 12 pi over 6. So let's subtract. Our first step is to find a coterminal angle. Okay, so we're going to subtract 2 pi, which is 12 pi over 6, and we get 7 pi over 6. So now we're going to draw that. That is down in quadrant 3. So our next step, that's our 7 pi over 6. Our next step is to find the reference angle. And that is the angle between our terminal side and the x-axis. So we've gone a little bit past the x-axis there, past that 180 in angles, that is pi in radians. Okay, so that's pi. All right, so we just need to find the difference between our angle, 7 pi over 6, and that x-axis, which is pi. So change that to 6. So 7 pi over 6 minus 6 pi over 6, that reference angle there is pi over 6. In this next example, we are going to try and find the values, the sine value that has other angles who have the same sine value as 40 degrees. Okay, so let's kind of estimate about where 40 degrees is. Okay, so that has some positive xy terminal point. Now the sine, that has to do with the y. And so over here in quadrant 2, we're going to have a negative x but a positive y. Okay, so that would be in quadrant 2, and so our reference angle is going to be the same. That's a 40-degree angle inside in here. Oops. All right, so what's that angle? Well, it's 180 minus the reference angle, which is 40. And so the angle there is 140. Has the same sine as 40 degrees. Okay, let's look at the one that has the same cosine. Well, cosine is the same in quadrants 1 and 4. All right, so our reference angle is still 40 degrees. Here in quadrant 4, we haven't quite gotten to 360. Our reference angle is 40 degrees, so we just subtract 360 minus 40. So that is 320. That has the same cosine value as 40 degrees. Okay, let's see, sine of 200. Let's see, 200 is down here in quadrant 3. So first let's find the reference angle, and then we'll figure out what angles have the same sine value. Okay, the reference angle is a little 20 degrees beyond 180. Okay, let's see. So back here we have a negative x and negative y. So we're looking what quadrant has a negative y, which is going to happen in quadrant 4. So we have positive x, negative y in quadrant 4. Okay, so we're looking for an angle that has in quadrant 4 with a reference of 20. Let's see. Okay, so this is 20 degrees. So this would be 360 minus 20, which is 340 degrees. Okay, our last one is what angle has the same cosine as 200 degrees? Well, cosine has a negative x in quadrant 3, and so we're looking for an angle in quadrant 2 that also has a negative x. So that reference angle we found earlier was 20 degrees, and so the one in quadrant 2, that hasn't quite gotten to 180, so our angle is 180 minus 20, which is 160.